In the diagram, P, Q, R, and S, can you all see P, Q, R, and S or cannot see? Can see, yeah? P, Q, R, and S, Okay, if I'm too fast, let me know. Lie on the circumference. P, Q, try to use your hands to go with that. P, Q, R, and S, it lies on the circumference. The circumference means the arc length. Can you see that? Okay, R, S, T is a straight line. Do you agree or disagree? Okay, so let's go to A first. The first thing we want to do, right, is to know what they want us to find. Sophia, you tell me what is it that they want us to find?
RP.
Yeah, where's RPS? RPS is this part over here. Can you see that? So if I can just bring you back to my notes, you realize that this is what we call angles in the same segment. If you cannot see, I'm going to just show it to you right now. We call this the butterfly. Yeah. Okay, not peanut butter, butterfly. Do you agree or disagree? So you might want to, because now that you're learning, I'm not saying that you must do this for your exam, but now that you're learning, you want to really highlight it. And maybe highlighting it too much will confuse you, right? So you want to draw it out as well. Is that okay? Just a quick sketch at the side. Just a quick sketch at the side. Okay, just a quick sketch at the side, just like that. Come down all the way to here, like this, like this. Just a quick sketch so that you can see that this is a butterfly. Since they both touch the same, are you able to see that this is 51?
Yeah.
This will also be 51. So angle RPS is actually equals to 51 degree angles in the same segment. Okay, so that's how you would do a question like this. Now, so once I'm done with this, I want to move on to the next one, which is what we call, the second one is what we call PST. I'm going to use blue color for the next one. Is that okay? So since you already know, right, that this is 51, since you already know that this is 51, right, you might want to really note down that this is 51. Is that okay? And this property is called angles in the same segment, right? That means the opposite one, right, is also the same. Do you agree or disagree? Now, the one that they want us to find is this blue color one over here. Can you all see it? Okay. Now, why do you say that it is 95? Do you say 95? Yeah. Why do you say that it's 95?
Yes.
Smart guess, huh? Okay, so maybe I want to help you with one thing first. Bit by bit, is that okay? All right, whatever we can find, we find first. How about that? Okay, what do you think you can find over here in this situation? What is something that you can find over here? Let's see, we zoom in a little bit. Sorry, tell me.
QRS.
Q.
I don't know, not QRS.
R.
QR, like the angle of R.
QRP. This one is it? But how do you find that?
I'm assuming that
Yeah.
it's 90 degrees.
Oh, you cannot assume that it's 90 degrees. You understand? All right. I would prefer if you were to look at this triangle over here. Okay, same thing. I'm gonna sketch this triangle out. Okay. Now, yesterday I was doing this same question, and there was some confusion. We assume, okay, you see, you cannot assume. You get what I'm trying to say? May I just talk about this first before you go on? How many of you would think, some of you would think that, oh, this and this is the same because they both come from the middle point. True. These are both radiuses, right? These two parts that I have noted down with that line. These are both what? Radius. But is it true that both of them are radius? No. Because in the question, they never even say that this is the middle. And in fact, you look at it, right? Do you think this is the middle? This is very skewed towards the right-hand side of the circle. Do you understand? So you cannot assume that it is the center. Understand or don't understand? Unless the question says so. Okay? And it's also quite obvious, right? Yeah. If it's the center, it makes our life very easy. We just say isosceles. True? But now we only have this RPS. So what we are going to do is we are going to use this RPS Okay, we are going to use this RPS to solve. This is how much? 34. This is how much? 51. Am I making sense or not making sense? And then we can actually find out this part over here. Can you see this part over here?
No.
All right, that is basically, sorry again? No, we basically have to use sum of triangle to help us to find, right? Angle PSR will now then be 180 degrees minus 51 degrees minus away 34 degrees. Who don't understand why am I doing this? Okay, you all understood, right? Okay, so this has to be, all right, let me just uh, calculate this. Okay, can somebody maybe help me also? You get to 95 degrees. So this entire thing is 95 degrees. May I just get you to quickly note down in your sketch? I tell you, when you note down in your sketch, right, it does make a whole lot of difference. I say that again, it does make a whole lot of difference. Okay, so we can see that there's 95. And I hope you realize that we are now trying to find the blue color part. Okay, all right. Make sure your question paper is by your side, okay? Yeah, by your side, so that you at least see where am I talking about. So whatever that I, draw on the paper or my question paper, can you please do likewise? All right, I double line this in blue color. You can also use a different color to go and do it. For now, okay, in exam, actually also possible in the diagram, can? So in order for me, because the question says I want to find PST, right? You all understand or don't understand? So angle PST, angle PST becomes 180 degrees minus away 95 degrees. That gives me how much? 85 degrees. And this is something, all right, or in fact, this is how you do a question like this. In the diagram, PQR is a tangent to the circle. What is the meaning of tangent to the circle? If I may just show you, the notes again. What is the meaning of tangent to the circle? Yeah, it touches only one point of the circumference. Am I making sense? All right, so let me just show you the notes now. Okay, so if you have the notes, please also, pull it out and keep drawing the reference. Okay, tangent to the circle. All right, in my notes, I wrote it over here. Okay, I have the one over here. As you can see over here, this is the one. Can y'all see it? All right, a tangent to a circle is a straight line meeting the circle only at how many points? 1 point. Can it be 2 points? Cannot. And then after that, we also learn, remember, radius that is perpendicular to the tangent. All right, so you see it touches here, right? Can you all see this part or not? Can you see this part? All right, and then this is another part, correct? Then this is the center, right? So if it's perpendicular, this is the radius, right? The radius is perpendicular to the tangent. Am I making sense or not making sense? Then later words, we also have to learn about rocket ship lah. Okay? Alright, so is this a rocket ship? No, unless there's another side to it, that kind of thing, unless it's like that. Okay? Alright, but in this situation, it is not. Okay? Now, the first thing we want to do is, what can we find over here? They say S lies on the circumference of the circle. So this is the one, correct or not? Okay, this is, okay, good information. Now, the only thing I can find is really just this. Okay, why am I finding this? Why am I finding this? Because the question says, I want you to explain why QS is not a diameter of the circle. Where is QS? This is the one. Do you all think this is the diameter? Well, how do we know if it's a diameter? It has to form a 90. What has to form a 90? Am I making sense? So what I want you all to write is this, if SQR is 90 degrees, then QS is diameter. Make sense? What? QS, right? Where is Q? Okay, so the first thing you can find is SQR, angle SQ. That's the only angle that you can find, right? Right? So you find angle SRQ, I apologize, right? It's equals to 360 degrees minus away 322 degrees. Do you understand or don't understand? Very good. So when you minus, what happens? You get to how much? 38 degrees. Where is 38 degrees? This is 38 degrees. Am I making sense? So now then the next thing you use sum of triangle, right? To see whether if this gives me 90. Okay, so we find that angle to be SQR. Are y'all following me? All right, 180 degrees minus away 50 degrees minus away 38 degrees. Is this something that you can understand? How much do you get? 92. So you see, this greatly proves one thing, right? That SQ is not the diameter. Am I making sense? SQ is not the diameter. Am I making sense or not making sense? So you just say, since angle SQR is not equals to 90 degrees, what can we say? QS, yeah, you must be specific. QS is not the diameter. How many of you agree with me on this? Okay, very good. Okay, so that's how you would do a question like this. The diagram PQRS. See for yourself. Do you see that this is what we call a quadrilateral in a circle?
Yeah.
If I go back to my notes, this was taught to you, or in fact, I asked you to write, right?
Yeah.
Right. This is the cousin. Why I say cousin? Because this is the cyclic quadrilateral. What is 3A? Aunties. The angle properties. Because under angle properties, there are three different types. Can you all see the yellow color part? Then the blue and the purple one is basically my cousin. Am I making sense? Then the five sisters is basically symmetric properties. Symmetric means symmetry, right? Right now. So that means same. Can? Okay. So I zoom into this. What did we learn about when it comes to angles in opposite segments?
Opposite angles
Add up to 180. Not 80, 180, right? You say 180, right? You understand? This is very different from the quadrilateral that is outside a circle. Because the one that is outside a circle is C angle. You all see the difference? I show you the difference. The difference is really just this, okay? The one outside, right, tells me that this plus this, let's say we have D and C, yeah, tells me the angle D plus angle C adds up to 180 degrees. But the one inside tells me that if I draw a circle, then it's different already. Can you see that? Angle A plus angle C adds up to 180. Are you all able to see the difference?
Yeah.
One is C angle, another one is just the opposite one. Can? Is that okay? Crystal, okay? I forgot to switch on. So we come back to this. Now, over here, can you all see? So you all understand why it's cyclic, right? Agree or disagree? Okay, whatever you can find, you find first. Shall we just find whatever we can find first? The first thing I can find over here is RQS. Where is RQS? RQS is basically this point here. True? Oh, we are so blessed. You know why? Because there's a middle point.
Yeah.
That middle point tells me a lot, right? Right. What does the middle point tells me? QPU. Let's see. QPU is 50. Why do you say that it's 50?
Because the 90 thing.
Very good. Okay. Okay. Are we able to see another thing like the butterfly? Are you able to see any butterfly? So butterfly, I usually have two fingers out first, and then I try to match. I try to match. What do I mean by that? You can see over here. Okay, butterfly, you can see 1, 2. Okay, so there's one butterfly over here. Okay, I know for now y'all cannot see, but I guess it comes with experience. Can see or cannot see? This is one butterfly, right? Okay, all right, then of course, are we able to see another butterfly? Are y'all able to see another butterfly? I can see another butterfly over here. Y'all see a butterfly over here? Are y'all able to see?
Now I do.
Are y'all able to see? That's another butterfly, right? Yeah. Okay, so whatever we can find, we find first. Okay, like I believe one thing that y'all can say, right, is that okay, since can y'all see this point? Y'all remember what is this about? This is about symmetric. Very good. Can y'all see it? Can y'all see it? Okay. Okay, all right. So can y'all see this? Can y'all see the 90 degree? Okay, you might want to even draw it out so that you can see, oh, that means this and this, they are equal. That means this and this, they are equal. This is 90, this is 90. This is under my symmetric properties of circle. Am I making sense here or not making sense? Okay, so of course, then from here, we just slowly find whatever we can find first. Can not? Okay. Okay, what else? What else? What else should we find first? Or what can I find first?
Can you say that QRU is
40. This is alternate angles. Where do you see the alternate angles?
From QPRS.
QPRS. But yeah, they never say that it's parallel. Because if you want this to be a alternate angle, then this has to be parallel to one another. right? This has to be parallel to one another. Okay, all right. So if it is parallel to one another, if it is parallel to one another, then yeah, we can say that it is. Then we can say that it is what? What do we call this? Z angle. You understand? But in this situation, it is not. Can? Okay, but I can see something called angles in the same segment. You all remember just now we talked about angles in the same segment?
It's
Yeah.
UQS.
Okay, okay, wait. Over here I see it as R. There's a lot actually. Do you all realize that? RQS. How many of you can see where's RQS? Let's use our finger. R to Q to S. Can you all see RQS?
Yeah.
RQS, that means to say they are referring to this point, is equals to RPS. Where's RPS? RPS. That means this point over here. Now, then if you're wondering, but where exactly is my, isn't it like that? Can you all see the butterfly? I know it takes a while to see, but actually it's not rocket science. You understand what I'm saying? As long as you can view it from the right perspective, right? Yeah, then it's okay. So you all must draw the butterfly out. Sketch it out. Even if it will get more and more confusing. You understand? Yeah, but well, the question will get harder and harder, but you can also get better and better. This is 40, and then this must also be 40. How many of you agree with me on that?
Yeah.
Okay, actually a lot of times, right, it's angles in opposite or angles in the same segment. It's a lot of that. You get what I'm trying to say? Yeah, so your job is to really have the uncanny ability to see it with your eyes. You don't have a telescope. You don't have like an angle scope. We don't know that. The only way, right, is to be more experienced. You see things differently. You asked me 10 years ago when I first started teaching, and it has been a decade that I've been teaching. I started at 17 years old, around your age, actually. 17 years old me and today's me is very different. The things I see, the things I know is very different. You understand? Yeah, okay. So this is how much? 40. Do you understand?
Yeah.
Go score. Then of course, what I want to do next, well, is to what else? Okay, so again. The question wants us to find what? RQS, right? Yeah, so actually I already know right now. Angle RQS is actually equals to what? 40 degrees. You all agree so far?
Yeah.
All right, so this is angles in. Let's practice the properties, okay? The reasoning. All right, you all know in primary school, you all do a lot of angles, and then you remember the angles on the straight line, angles in the circle, right? Yeah, so over here is same thing, okay? Understand? Where is QSR? Go and note it down first. QSR. Hey, QSR is actually here, leh. Can see or not? QSR is actually what? This part over here. Do you agree or disagree? How many of you can see? Okay, all right. Butterfly, very good. Can you all see another butterfly? I don't know if you all can see another butterfly. Let me just note it down with a, yeah, see, the moment you practice, actually it's not rocket science anymore. Understand? Can you all see the butterfly? Okay, but of course, because it's a butterfly, I need to find this man. True? Why 50?
Because
it's a right angle. Why is it? Where is the right angle? This one with this one. Do you all agree?
Yeah.
You all agree or disagree? Okay. Can see or cannot see? Okay, one more time, Sophia. See this one. Can you see this one? With this one. It's actually a right angle. All right. You cannot see, never mind. It's okay. Just draw it out. Always sketch it out. Then you see from a different perspective. Can you all see the right angle? Next time when you all go to higher level, you all must always remember anything that you don't know, you write out, you pen it down first. You practice the writing part. It's so simple yet so difficult to grasp, right? Because sometimes we don't want to write out. We want to do everything in our minds. It's a no-no, okay? Are you all able to see the 90 degree now after I've sketched it out? Okay, so in that case, right, this 90 degrees is split. Am I making sense? There's one part that is 40, then the other part, automatically we know, right, that it is basically what we say. What do we call that? 50. Are you all understanding or not understanding? So the entire part is 50 degrees, right? So that means to say this part is how much? Yeah, I apologize. The entire part is 90 degrees. So this part is just 50 degrees. Do you all understand? But you must give the reasoning. Don't you agree? Must you give the reasoning? Yes, you must give the reasoning. Okay. So let me just quickly check this off first. Okay, let's give the reasoning. Angle QPS is equals to 90 degrees. We call this right angle in a semicircle. Am I making sense or not making sense?
Wait, what is this, sir?
Okay, let me explain. Now, this is the property that we use. Okay, or you want to write right angle in circle also can. Okay, but what we like to do is, okay, you see, the question wants us to find QSR, right? Which is QSR, which is this one over here, correct? Yeah, so we can say that this one is what? This entire thing is 90, right? 90 minus 40, that is 50. True? Yeah, okay, this is the property. This is the reasoning. Am I making sense? Okay, do you all remember this one is under what? Do you all recall or you all don't recall?
Which one?
Like this property? Or is it under?
Auntie,
Sorry?
auntie,
Huh?
three auntie.
Three auntie, yeah. Three auntie. It's not, I don't think, no, it's not symmetric.
No,
It's not symmetric.
no, auntie is angle, right?
Or three auntie.
Oh,
No, that one is under just the quadrilateral only. One auntie ma. Got three auntie man? Three auntie, right? Three auntie is angle properties. Where's the 90-degree part? This one? Right angle in a
semicircle.
semicircle. You all see? Right angle in a semicircle.
Mm.
If you're wondering where's the semicircle, actually the semicircle is just, you want to see where's the semicircle? The semicircle is just here, right? You know? Can see it now?
Oh, wait.
Yeah,
Can see a semicircle?
Oh.
Yeah. Alright, another one is actually here also. True?
yeah, that's
Yeah,
how we
I
found
used
it
that.
out.
Yeah, right? What else?
That's it.
Yeah, because you already know that this is 90-degree, right? Right now. Then your job is to, okay, maybe some of you still cannot see, but actually your job is to find out this one. I show you all, okay? Your job is to find out this part. Can you all see?
Mm.
You understand or don't understand?
Oh,
Can see? Can you all see a triangle?
Yeah.
Can see a triangle?
That's it.
Yeah, right? So then this is 90, right? Correct now. What is this Q, this QS, this R, right? Correct now. This is how much? 40. Agree so far? So you want to find which one? You want to find this one over here. Can you see the black color one over here?
Yeah.
Can see or not? That is what we want to find, right? So angle QSR becomes how much? 50 degrees. Agree so far? If you're wondering how to get 50, because 180 degrees minus away 40 degrees minus away 90 degrees. Make sense? 50 degrees. What is this called? Angle, sum, the basics of the angle. Okay, one more time. Teacher Joseph is finding this one. You see? If I know that this is 90, right? Then this has to be?
50.
Yeah. Why? Because 180 minus 90 minus 40 equals to 50. Do you agree or disagree?
Yeah.
Agree, yeah? Can I? Alright, that's all. POQ. Where's POQ? POQ is this point over here. Do you understand?
Yeah.
Okay, so if we can find that point, that would be great. Okay, maybe we look at what points can we find first?
QOT.
PQS.
PQS. Okay, why do you say we can find PQS first? Alternate angles. How do you know it's alternate angle?
Oh, wait, no.
Yeah, you just now Sophia also say, right? Alternate angle, but then alternate angle only comes when I have parallel, but they never say you cannot assume. You understand what I'm saying? Okay. Q. Oh, very good, very smart. Let's move in. You are so smart. Let's move in. Where is QOT? Where is QOT? Where is QOT? Correct or not? You all agree that this part. Can see the green color part, right? Can find that one, right? Why? Use sum of triangle, right? Right? So you see, so I draw this out first. Huh?
Wait, there's you can just infer it from QSR.
Okay. Yeah. Can you all see this is 40 degrees? This is 90 degrees. This is how much? 180 minus 90 minus 40. Go back to the same thing. How much is that? 50 degrees. Agree so far? Then do you all agree that this P to T, oh, but is P to T a straight line?
Yes.
Yeah.
Okay, very good. Okay, let's find OTQ. Okay. Well, but if you are going to say that it's a straight line if it's QOS. You understand? Yeah, but actually, because you see, OPOT, right? It doesn't go all the way. So we cannot assume that it's a straight line. You understand? It's only the diameter that is a straight line. So I do agree that this is 50. Everyone agree with me on that? I 100% agree that is 50, right? So in order for me to find this, right, I have to find this one first. Then I do. Then I do what?
Wait, can you do vertically opposite?
Cannot. Vertically opposite angle is when I have two straight lines. But in this situation, do I have two straight lines? I don't have two straight lines. You understand what I'm saying? Okay, so let's find OTQ. What is OTQ? We know it's 90, right?
Yeah.
Okay, what about if I were to find POQ? If that part is 90, you see, if this part is 90, right? Can you all see this 90? All right, isn't this just external angle? This blue color one, can you all see this blue color one?
Yeah.
You know this is 90, right? Can you all see external? You all remember what is external angle?
No.
Okay, never mind, it's okay. Then we can just go by the simple ones, okay? We can find that this is 130, correct? This is also 50, true? Then this is 130 again. Do you understand? Right, because, okay, I zoom in again now one more time. Can see this is 50, this one, y'all agree that this is 50? You all agree that this is 50, yes or no?
Yeah.
Can you see the screen?
Yes.
All right, then this one is 130, true? Why is it 130?
QoS is straight line.
It's a straight line. QoS is a straight line. 180 minus 50, that gives you 130, right? Then after that, I continue on. I can find this part over here. But actually, yeah, that part, you see, this is not straight line also.
Yeah.
Right? POT is not straight line. You get what I'm trying to say? Yeah, so then this method is not going to work out anymore. You get what I'm trying to say? Yeah, so I cannot do it this way. So this one I want to cancel. Okay, I'm going to help y'all can. Okay, we write this down first. Y'all ready or no? Okay, let's see whether if we can find another way to find this blue color angle. Okay, all of this I agree. All of this I agree. Are we able to find another angle that will help us? Let's see. This one I'm very certain that is how much? 130. True? All right. Yeah, you really have to use exterior angle of a triangle. The exterior angle of a triangle is super important. Exterior angle of a triangle. Do you all know what is that? Okay, I can I draw it out for you all to see? You see Q to T. Can you all agree that Q to T is like that? Then I go all the way to here, right?
Yeah.
Then let me see. I go all the way here. Then I go all the way down. This is P. Can see?
Oh,
Then there's another one to O. True? I know that this is how much?
50.
50, correct. So I'm trying to find this part over here. Actually, you look at this one. So you cannot say angles on a straight line. You can only say exterior angle of a triangle. You understand? Which gives me 180 minus away 50. That gives me 130. Can you understand? This is 90, right? True? True. How much is this? 40, right? Make sense? Yeah, so the only way to find out what is this really is to do 90 plus 40 gets. Okay, you all remember now? This angle plus this angle gives me the one outside.
Yeah.
Okay, I redraw. Do you all know that? No, okay, let's say if I want to find this one, right? In order for me to find this one, this plus this is actually equals to A plus B is actually equals to C.
Oh, that.
This is called exterior angle. Understand or don't understand?
Oh.
You all remember? I know it's a very, very, very long ago.
Wait,
thing.
but this is still the assumption that this is a straight line.
No. Because this is exterior angle of a triangle. I'm not using assumption. I'm using exterior angle of a triangle. Can you all draw this out? So you know, oh, then this is A, B, and then that 130 is my C.
Okay.
Do you all understand?
Oh,
Yeah, you have to use something that is of the properties. I'm not assuming that it's a straight line. I never say it's a straight line. Correct or not? I say exterior angle of a
Triangle.
triangle. You want to note that down in your cheat code book. All right, just draw this out. Okay. All right, then we call this exterior angle of triangle. Do you all agree so far? Okay, note this down. You won't find it inside this. Yeah, you have to take out your cheat code book and then you have to write that. Yeah. Is that okay?
Yeah.
Okay. All right. So yeah, that's basically how you would solve. May I go back to the question? Are there any questions that you wish that I can answer? That you say, teacher Joseph, you better answer today before. If not, tonight I cannot sleep. Okay, yeah, I mean, sorry. For C itself, are there any questions that you want me to answer? Is it clear for you, sir?
Yeah.
Is it clear for you? Is it clear for you? Okay, very good. Is it clear for you, Krista? All right. Okay. Now, so we know this already. Then again, guys, remember to use a pencil. I say this a lot of times already. Okay. All right. So we are going to quickly note down first. Okay. Don't be afraid to use different colors. Three colors that you can always depend on. You can rely your whole life with: green, red, blue, or black. Just use these three colors, you usually won't go wrong. You get what I'm trying to say? In your diagram. Okay? Alright? Understand or not understand?
I didn't actually.
For C, the first thing we want to do is to find QTO. Understand? I never say, Lawrence, I never say that you're a QT, yeah? But QTO, okay? Alright, so QTO is basically, again, like I said, 90 degrees. Okay, what is the reasoning for this? What is the reasoning for this? We call this, let me just show it to you. If you can find faster than me, I give you 1 point. Okay, we call this what? Bisector of chord. Do you all know what's a bisector of chord? Do you all know why this is a bisector of chord? You can follow my cursor. Can see the bisector of chord? Can see? I do a few times, huh? Can see or not? Yeah, okay, so this is what we call bisector of chord. Not chord. Okay, now, so that part is done, right? That part is done, right? Then we're gonna find angle POQ. Huh? Again, like I said, angle POQ is the one outside the triangle. Cannot use angles on the straight line, okay? Can or not? Okay, angle POQ. POQ basically is 100, sorry, not 180, but 40 degrees plus what? 90 degrees. That gives me how much? 130 degrees. What do we call this? Exterior angle of a triangle. Is this something that you can understand? Okay, so that's all I have for you for C. QUR. Go and note down where is QUR first. QUR is this angle over here. Can you all see this angle over here? Okay, maybe I just want to make it bigger like that. Can you all see? Okay, how do we find this? How do we find this? Oh, sorry, it's the other way around. QUR is this one over here, right? Okay, well, you can see a triangle, right? Yeah?
Sure.
Okay, you can use the triangle. Maybe if you can minus away this, then you can immediately find that already. Do we know that? Do we know what is that? Let's see, do we know what is that? We see whether, okay, we don't know what is that, okay? Is there anything else that we know? Is there anything else that we know? Let's see, whatever we can find, we find first, okay, they say OQP, okay, I don't think I want
OP, okay, POS is 50.
wait, which one? P what? POS. Why do you say POS is 50?
Because
Angles on a? Yeah. Can see? Can see the QOS as the diameter, as the straight line? Do you agree or disagree? Okay, 50 is over here, yeah? Can, Okay. What else? What else? I know. Okay, journey with me. Anything that comes from the middle point, yeah, right, has the same measurement.
So it's an
P,
isosceles.
correct. This is an isosceles. OPS is an isosceles. Are y'all seeing it?
Yeah.
Are y'all seeing
So
it or no?
25.
Yeah, what is 25?
PQO and
Correct.
QPO.
Do you understand,
Huh?
Lawrence? Hey, wait, PQO.
and
OP.
P.
This one, right? This one, right? This one and this one. There are many. There are many. I know you see more than one. Do y'all see it?
Oh.
Can see or cannot see?
Oh, I can see it.
OPS, can see?
Okay.
Yeah.
All right. I zoom in a bit, Can I zoom in a bit?
Oh, you're looking at the other one.
Yeah, there's too many. As long as the measurements comes from the middle point. Okay, there's one here. I follow my cursor. One. Can you all see this? Can you see this triangle?
Yeah.
Yeah. So which one is OS is equals to OP? OS is equals to OP. OS is equals to OP. OS is equals to
You
OP.
can find PSC.
OS is equals to OP. Am I making sense?
Yeah.
Okay, so we are going to find, let's find whatever we can find first. Angle OPS.
But the answer should be
Understand?
that.
Okay, is equals to angle OSP. Am I making sense? 180 degrees minus 50 degrees. You divide it by 2, correct? Don't need to write in fraction form, just put divide by 2 over here. Can? All right, we get to 65 degrees. You all agree or disagree? Can you understand? Can you understand?
Yeah.
Okay, all right. So I will just stop here for a bit. So since we know that this is 65, right? I'm just going to erase this. You can see that this entire thing is 65, correct or not? So then this is how much? 25. Do you agree? Do you agree? Okay, because I am looking at this triangle. I'm looking at this triangle. Can see or cannot see? Can you all see this triangle? Yeah, this is the triangle that I'm looking at. Make sense or don't make sense? Okay, so then of course this part over here is how much? Also 65. Do you agree or disagree? Okay, all right. So I can also find another one. Okay, because we are trying to find this one over here, right? Correct or not? True? You are trying to find this one, right? Yeah, actually you can just use, I'm gonna use another striking color, maybe a green one. We can just use this triangle. Can you see this triangle? Can you see this green triangle?
Yeah.
What did I say about the green triangle? Exterior angle. You all understand? Can you all see the green triangle? So actually, this one over here, this question mark over here is solved by using 50 plus 75. 50 plus 25. This one, this 25. Can you see this 25? And this 50? Right?
Yeah.
I when I add up, it gives me the outside over here. Do you understand or don't understand? It gives me the outside over there. Am I making sense?
Yes.
So let me just draw out the triangle as well. Okay, I'll just draw out the triangle. I'll draw out the triangle over here. Correct now. I'm trying to find this one over here, right? Correct? Can you all see? Are you all following? Okay, you see, I make sure I sketch as much as I can. Can? This is 50 degrees, what? Correct not? Then this is 25 degrees. You all agree so far? How do I find this angle outside? How do I find OUR? Angle OUR is basically equals to 25 degrees plus 50 degrees. That gives me how much? 75 degrees. Do you understand or don't understand? Okay, so yeah, that's how you would do a question like this. Well, so when I see a question like that, first thing first, identify that, okay, this is parallel, so it's very important. You can see a butterfly over here. All right. So what I want to do is note down this butterfly. If you can sketch it out as well, I think that will be very, very helpful. Okay, so you say that this part and this part, they are the same. So this is 36. This has to be 36 as well. Make sense?
Yeah.
So this part over here has to be 36 too.
Yeah, another alternate.
Very good. Then alternate angle already. So then you can find AEB already. Isn't that true? Okay, but before you want to say AEB, you must obviously practice, or in fact, you have to say that XBE, do you agree what is XBE? Is equals to 36 degrees. What is this called? Angles in same segment. Practice writing this down. You understand what I'm saying? All right. Then to find angle AEB, we will just have to say 36 degrees or so. We call this alternate angle. Okay. And that's basically how you would do a question like
Yes. Wait,
this is 36 degree, right?
Yeah.
There's no center. I just wanted to tell you that, okay? Where's my BAE? Where's my bay? Where's my bay? My bay is this one over here, right? Can see?
Yeah.
Just now I talked about how cyclic quadrilateral, a quadrilateral in a circle. Can you all see? Opposite must add up to 180 degrees. So to find out what is this over here, can you all follow my cursor? I just have to look opposite, right? This part plus that part is actually equals to how much? 180 degrees. Yeah, because, well, there's no center point, right? You get what I'm trying to say? Yeah, there's no center point. So are you understanding or no? Okay, so BAE is 180 degrees minus away 75 degrees. I get to 105 degrees. Okay, what do we call this? We call this angles in opposite segment, not same segment anymore. Opposite segment. Can you all see it's literally opposite, right? If I go back to my notes, right, it becomes, I don't know if you can see. This is the one, the purple color one. Can you all see? All right, this is the C, the one cousin, because there's one concept in cyclic quadrilateral. Okay, all right, opposite must add up to 180. Opposite must add up to 180. Do you all agree or disagree? Okay, so then this has to be 105. Make sense?
Yeah.
So that means, yeah, okay, so that means I'm done with BAE. Is that okay? All right, of course, well, once I'm done with that, I want to move on to the next one, which is, okay, I hope everything is clear for you. I hope everything is clear for you.
This is another BXAE is another quadrilateral. So you can just
Oh, is it a quadrilateral again?
It's parallel. It's parallel.
BXE, yeah.
Okay.
BXE is this point over
BX
here.
Yeah, BXE.
This is the question mark over here.
Oh,
True?
okay.
Yeah, but you cannot say it's quadrilateral because
Why?
it doesn't touch the four corner. So you cannot say, oh, then I just have to do 180 minus 105. No, it's not. Because it has to touch the four corners.
Wait, but BX and AE are parallel.
BX and AE parallel. Yeah. Go on. But if this is in a circle, it's in a circle. If it's outside a circle, yeah, I agree with you.
Okay.
But because it is in a circle, so then things will be a little different, okay? What if I get you, what can you find first? Is there anything that you can find? Shall we go back to angles in the same segment? Do you see any another butterfly? I saw another butterfly. Can you all see another butterfly? This one over here. True. All right, I erase away this color. I highlight again the butterfly. Can you all see? Can see my butterfly?
Okay.
Can see another butterfly? So 75
75.
degrees first. Understand? Use your butterfly to help you to get the answer, okay? Can you understand? All right, angle BCX is equals to 75 degrees. We call this angles in the same segment or opposite segment? Same. All right, angles in same segment. Is that okay? All right, whatever you have, you can just check it off first. Can? Well, what else? What else do I have? What else do I have?
Okay.
Can we say E is 36 also?
E, let's see E. Yeah, is E also E? What is E? You meant
Like
BEX?
Can we say it's
Well,
also 36?
how do you know that? How do you know that?
Since AE and BX are parallel. Oh no, cannot because it's inside the circle.
Yeah, it's inside the circle. Correct? Okay, let's see. Can everyone go to CBE?
CBE.
What do y'all see for CBE?
Is
180 minus 36 minus 75.
180 minus 36 minus 75.
Oh wait, no. Can you? Oh, no.
How many of you realize that? How many of you realize that this is true?
Oh yeah, because of the
True.
What's the difference between BAE not being isosceles and BCD being an isosceles?
BAE. Okay, BAE could also be an isosceles triangle. Yeah, because you see, can y'all see? Okay, let me just erase this first. I erase this, okay? All right, can see this part over here? This is the triangle that I'm looking at. Is that okay?
No.
Do you agree or disagree? Agree, right? Yeah, so what can we do for that part?
180 minus 75 minus 36 divided by 3.
No, actually, no. We cannot assume that this is isosceles, right? Because it doesn't come from the center. So this part doesn't work anymore. Cannot. Okay. What else? What else? What else? What else? What else can we find? B, C, E.
Like,
Okay.
is that triangle an isosceles?
Oh, it's not how do you know that it's an isosceles? No, that is not. What about this angle over here?
Right. No.
Do we know that? CBX. We can find that. Angle CBX. Okay, we see whether. Oh my goodness, you know what? The question actually told us, but we didn't read. The question stated so clearly that CE is equals to BE. So actually, this is an isosceles. But you see, we don't. The problem with us, right, is that we don't read. You get what I'm trying to say? It's like given to you, but we don't read. So isn't this isosceles to this?
Ow.
Is it clearer now?
Yeah.
Yeah.
So
It's very clear now, right?
75 minus 36.
Correct. 75
39.
minus 36. You understand or
So
don't understand?
75 plus 39.
So we know CBX is what, right? CBX is basically 75. CBX is actually 75 degrees minus away 36 degrees. Correct or not? That gives me 39 degrees, right? So this is 39 degrees. You understand or don't understand? Our job is to find what?
Oh, BXE.
The back.
Yeah, actually you can use exterior angle again. How many of you can see the exterior angle again? Can see exterior angle again? I show you the exterior angle. Is that right? This is the triangle, right? Exterior triangle. Can you all see? Yeah, 114 is correct. Okay. Can see or cannot see? So this one, right? This is 39, right? Are you all able to see? All right. This is 39, right? Correct or not? And then this is 75. Agree so far? Agree or disagree? All right. So how do I find this part over here? How do I find this part over here? Again, like you said.
I love 40%, 500, 140.
Okay. So you to find that one over there, we basically just have to do that is basically angle BXE, right? To find angle BXE, we just have to do 39 degrees plus 75 degrees. You understand? That gives me 114 degrees. Make sense? All right. Exterior angle of triangle. Do you agree or disagree? All right. So yeah, that's basically how you would find this question. Now, 53. Are you ready for 53? Are you ready for 53?
Yeah.
Again, 53. Well, we can find ADC, right? Actually, ADC is which one? This is the one. Can you all see? Can see ADC? Can see ADC? Yeah. What is this called? Angle at center is 2 times at circumference. Am I making sense or not making sense? Okay. So of course, what we want to do is we want to find angle ADC. True? All right. Angle ADC is basically just 4x degree. All right. Listen, okay. To find this one itself, you can see rocket shape. Can see a rocket shape?
Yeah.
Can see a rocket shape? Right. The concept that I've taught in rocket shape. Let me just show it to you. Okay. Under my notes, you can see rocket shape, rocket shape, rocket shape. Where are you? I believe it's here. Can see? Where is rocket shape? Okay, let me just zoom out. Ne? Ding, 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 ding. Where's my rocket ship? Rocket ship. Can see? Can you all see this? See for yourself? Not really rocket ship. What is this called? Boomerang. Right? The one, listen, the one at the center, the one over here is double of this one. If this is 50, this is 25.
Yeah.
If this is 140, this is 70. Make sense? So use the same idea. If this is 4x, this has to be 2x. Am I making sense? Yeah, so 4x degree divided by 2, that gives me 2x. So you must write down angle at center. Angle at center, what? Is 2 times what? 2 times what? At circumference. Can? Understand? All right, so that's 2x. Easy? Easy? Okay, so then after that, now we want to move on to the next one. Okay, understand or don't understand? Okay, the next one we have is this angle over here, 5x plus 5. And they want us to find what? What do they want us to find? They want us to find the value of x. Agree? How do I go about this? Well, I don't know if you all remember cyclic quadrilateral. Can see this is a 4 point. Can see 4 points? Can you all see this part that I've highlighted?
Yeah.
Means what? 2x. Okay, so I draw it out for you to see. Okay, I draw it out for you to see. Just imagine it being in a circle. Can you all see it? Yeah, it's 25. That's correct. Okay, can see that this is 5x plus 5, right? Do you agree or disagree? Make sense? This is how much? 2x what? True? Do you agree that this is 2x?
Yeah.
So that means what? Opposite adds up to 100 and opposite adds up to 180. How many of you agree with me on that? Right, that is what we call angles in opposite segment. Do you agree or disagree? Right, so yeah, to find the value of x, I'll just form an equation. All right, let me just show you angles in opposite segment. Yeah, how do I know these angles in opposite segment? Because it touches 1 point, 2 point, 3 point, 4 point, correct? Of the circumference of the circle. True? Yeah, so you just have to say 5x plus 5 plus 2x is equals to 180 degrees. Make sense? Make sense?
Yeah.
7x is equals to 180 minus 5, right? So 7x is equals to 175. Is this something that you can understand? So x is equals to 175 divided by 7. That gives me 25 degree. Okay, and therefore this is your answer for this question. Now, whatever I can find, I find first. Can? Okay, what is something that I can find? You can see BCO is how much, right?
Yeah.
How much is that?
180 minus 132 over 2.
Very good. Why? Because BCO is this part over here, right? Yeah. If you all can see that this isosceles, why is this isosceles? Because it comes from the center. Am I making sense? Yeah, anything that comes from the center has to be the
It's all cycle
same. Yeah,
And
because
it's
it doesn't
not
touch the front. Okay. So let's do BCO first, Ken. Angle BCO is actually how much? What is BCO? 180. Are you all able to see why this is an isosceles?
Yeah.
We are not assuming, right? What are we doing? We know it, right? Because it comes from the center, then the radius. You understand what I'm saying? All right. So then of course, when I do 180 minus 132 divided by 2, that gets me to how much? 24 degrees. You all understand or don't understand? Understand or don't understand? Okay. So we have these two. All right. We have these two. All right. So I know that this is 24. All right. I also know that this is 24. Do you agree or disagree? Agree or disagree? Okay. Then they want us to find BAC, which is this part over here. True? All right, BAC, I don't know if you can see. This is what we, okay. So tell me, BAC, can you all find BAC? Do you all know what's BAC? We cannot use cyclic, right? Can we use cyclic? Cannot. Agree or disagree? Can we? Cannot. But BAC we can use. Okay, first thing first, angle at center, which is this part over here, is double the angle at circumference. This is double of this.
Oh.
Okay, you see center, then you see the point, then you can see it. Agree?
BAC, oh my.
Okay. All right. So 114 is correct, but let's note it down first, shall we? Shall we just note it down first? Okay, so to find that, we have to understand. We cannot memorize, we have to understand, okay? Why is it that I say angle at center is 2 times? Because you can see this is the center, right? Right? This part over here is the circumference. Agree so far? So angle BOC, let's find angle BOC first. That is basically 360 minus away 132 degrees. Do you agree or disagree? Agree or disagree? Okay, so that gives me how much? 228 degrees. Agree or disagree? 228 degrees. Make sense? Okay, all right. So then this is 228 degrees. What we want to do is we want to find out what is this part over here. Can y'all see this part over here? All right, which is what the question wants us to find, which is BAC. Make sense? All right, 228 degrees, you divide by 2. Oh, wait, before I go on, right, can I just write this as what? Can I just write this as what? Angles at a point. Am I making sense? Okay, angles at a point. Do you agree or disagree? Okay, when I do 228 divided by 2, I'll get to 114 degrees. Make sense? Okay, what is that 114 degrees? That part is called angles at center. Angles at center is 2 times angles at circumference.
Right.
Do you understand or don't understand? All right, so this is 114 degrees.
I think there's a better way to name it other than BOC, because it's already BOC.
BAC?
No,
BOC is the outside, ma. Or you mean the inside? Okay, but how else? No, you just have to say reflex BOC.
Oh.
Reflex BOC. Make sense? Because BOC, I understand BOC is inside. I see your concern. Very good. Okay, so that's basically how you would do this question. So the next thing I'm trying to find is basically ABC, which is this part over here. True? True or not? Lawrence?
Yeah.
Can see? All right. So my job is to say that, oh, because this is parallel line, huh? Can see this or cannot see? Can see this or cannot see? Can see, right?
I got 40.
So you see that this is also equals to Z angle, right? So this is also equals to 24. You all agree so far? Yeah. So now we are trying to find angle ABC, right?
40.
Okay, so angle ABC is basically how much? 180 degrees
Good.
minus away 114 degrees minus away how much? 24 degrees. Do you agree or disagree? Did y'all do it this way or y'all didn't?
I did it.
Okay, so yeah, that's the reason why ABC is actually equals to 42. I think this is relatively simple. True? Okay, then BTC, Bitcoin. Now, BTC is this part over here. So we are trying to find this one over here.
Is it can you not use standards from an external point?
Can you what? Exterior
I mean,
angle?
no, but no, I meant like
It's not a right angle, so cannot.
yeah.
Right? It's not a right angle. Okay.
Yeah.
Well, but there's one thing for sure. Very good. How do you know OCT is 90? OCT is very good. OCT, I show
When
you
we
where's
assume that.
OC. No, she's not assuming.
When the time
Like that, ma. Can see?
90.
Can see?
Huh?
This line over here and this line over here. Can you all see? Right, so that OCT, that means this point over here, right? This entire thing is how much? 90, right? So we can actually just find one of it, right? Correct or not? Make sense? Okay, so you don't know, it's okay. As long as you learn. Alright, so OCT is basically how much?
90 minus 24.
90 degrees minus away 24 degrees minus away 24 degrees. You agree so far? 42 degrees.
Does that mean you're finding ACT?
Yeah, I'm trying to
Yeah,
find it slowly, right? True or not? Okay. Can you understand? Okay.
Okay.
No, sure. I'm thinking because your ACT is 42. You put OCT on the right.
Oh, sorry. I should
Yeah.
put. Sorry, you're right. It should be ACT.
Oh,
I should put angle OCT is what? 90 degrees,
degrees,
right?
yeah.
What is this called? What is this called? That okay, tangent. No, tangent is perpendicular to the radius. You all remember the tangent? The tangent is the line that is outside the circle, right? It's perpendicular to the radius. When the radius extends, what happens is that they will form that 90 degrees. Make sense or don't make sense?
Yeah.
What else do I have?
And then
TAC.
BT is a straight line, right? So
BT is a
180
straight
minus-
line.
Yeah.
Are we assuming that BT is a straight line or we know? We
I
know because bat is a straight line.
Aha.
Understand so far? So we can actually use that. You're right.
Given.
Okay, we can use this. All right, we can say that 180 minus away 114. Make sense? Do you understand or don't understand?
Understood.
Is that what you did? Okay, very good. So then you see, use whatever. It's not rocket science. It's not very difficult. You get what I'm trying to say? Can you understand? Sorry, it's not BAT. BAT is a straight line. Very good. So we say angle CAT. Yeah. Okay, is equals to 180 degrees minus away 114 degrees. You understand or don't understand?
Yeah.
All right. When I do 180 minus away 114, we will get to an answer of how much? 66 degrees first, which is this part over here. Right? Agree? What is the reasoning? Angles on a straight. Whatever I got it. Straight line. Understand or don't understand? Okay, of course, then now we want to go on to find CTA. Agree or disagree? All right, 180 degrees minus away 42 degrees minus away 66 degrees. Are you understanding? All right, we will get to an answer of 72 degrees. Okay, this is sum of angles in triangle. Okay, so that's how you do a question like this. Now, question 55. They say in the diagram, the points A, B, C, D, E. How many of you can see A, B, C, D, E? Well, you can see that this is a cyclic quadrilateral. Am I making sense or not making sense? Okay. All right. So then they say that AD is parallel to, very important point, right? AD is parallel to what? AD is parallel to BC, which is this 2 point, yeah? So we can later use the Z angle, yeah? Can you all see the Z angle over here? Can see? All right, can see, yeah? AD is the diameter. Did they say that? Yeah, they did say that. So you all must learn to read, okay? Then the rest don't need to read it because the rest is already written down for you, correct? You all agree so far or don't agree? Agree or disagree? Okay, let's find the first one, which is what we call ABE. Where is my ABE? ABE is basically this point over here. Okay, let's note down that point, which is this one over here. Can you all see it? Can see it or cannot see? Can see, yeah? Okay. What else can I... Is there anything that I can do? Like anything about the center or the... Where's the center? Where's the center? If AD is the center is the one over here. Can you all see the center is the one over here? So we cannot use the angles at center is double or make sense? We cannot use that. Okay. But we definitely can use, let's see, let's find ABE first. Where's ABE? ABE is the one over there, right? Can you all see butterfly? Who can see butterfly? Can see a butterfly?
Yeah.
Why you laugh when I say butterfly? Okay, angle ABE, right? It's not rocket science, huh? Okay, I say first, All right, can you all see ABE? Can see or cannot see?
Yes.
Can see, so we say that this is 53 degrees. Angles in
Same segment.
There is BDC 31.
angles in same segment. You understand or don't understand?
Mm.
Okay, can all right. So what we want to do now is we know that this is 53. Okay, so we want to note down inside our figure, right? What else do we have? What else do we have? That is done, right? In fact, that is done, right? Let's move on to the next one, which is DAE. Where is DAE? Where is DAE? Can you all see DAE? Can see DAE? Where's my DAE? My DAE is this one over here. True? Do you understand or don't understand? All right, my DAE is the one over here, right? So which one over here? Let me just show it to you. All right, this is the one that I'm talking about. This one. Can see? Can see or not? Okay, who can find?
180 minus 90 minus 50.
Okay, how do you know it's 90 though?
The AB
It's
is
half the
diameter, and then
AED is
So,
90.
wait, which one is the 90 degree? AED, okay, DEA, AED, same. All right, how many of you agree that this is 90 degree?
Can you assume that?
Lawrence, I'm not assuming. I'm not assuming. Why am I not assuming? Because remember, just now I said about right angle in a semicircle.
Oh.
So I'm not assuming, right? Correct not? Guys, you all must know the reason for AED to be 90 degrees. What is the reasoning? For AED, for angle AED to be a semicircle, that is a reasoning. We will just say that this is 90 degrees, correct? Over here we say what? What do we say? Angles in, sorry, not angles, but right angle in a semicircle. Do you understand what I'm saying?
Yeah.
Right angle in a semicircle. Agree so far?
Yeah.
All right, so this is actually 90 degrees. Make sense or don't make sense?
Mm.
Okay, so let's move on to the next one. Okay, we can find out what is this over here, right? Which is DAE, right? Can we find DAE? So we can find DAE already, right? We just have to use something called sum of angles in a triangle, right? 180 degrees minus away what? 90 degrees minus away 53 degrees. Make sense or don't make sense? Okay, 180 minus 90 minus 53, we get to an answer of how much? 37 degrees. Which is 37 degrees? This is 37 degrees. Understand or don't understand?
Yeah.
Okay, so that is my DAE lah. Make sense or don't make sense?
so
Okay.
for BED, is it
Yeah.
53?
BED. Okay, why do you say it's 53? Why do you say that? No, it's not 53. Let's see next one, which is BED. Yeah? Where is my BED? Can we identify that now? Okay, BED is this one over here, right? Can see? Can see now? I don't know if you all can see the. Can you all see this is angles in opposite segment? Can see that?
Can we do butterfly?
Butterfly, very good. Angles in same segment, right? Are you able to see or no? Can see or cannot see? So you can see where's BED, right? This is the one that I'm talking about, right? Correct? Okay. Can you all see angles in opposite segment or you cannot see? Opposite adds up to 180 degrees. Make sense?
Oh, it's a quadrilateral.
Show it to you. Are you able to see it? Yeah.
Can you, wait, I was gonna ask, can you assume FDBC is a normal quadrilateral?
What do you mean by it's a normal quadrilateral? As long as there are four sides, it's a quadrilateral.
No, I meant like BFD equals to BCD equals to 1
BFD equals to
1.
BCD.
Yeah.
No, but you have to touch four corners, right? You remember what I say about four corners? You have to touch the circumference, right?
Then wouldn't it be
Can you see or not?
Oh.
Right, so then
No,
this and this,
doesn't
right?
touch the
Am I making sense? Yeah, so angle BED, right, now becomes what? Angle BED becomes 180 degrees. Listen, minus away 112 degrees we get to an answer of 68 degrees. What do we call this? Angle in opposite segment. Am I making sense or not making sense?
Sir, can I drink?
Do you understand or don't understand?
Understood.
Yes, you can drink.
Got
Do
it.
you understand why BED is like that?
Yeah, it's a quadrilateral.
Yeah. Okay, make sense or don't make sense? Next one is BFD. Where's BFD? BFD is this one over here, right? True or not? True?
True.
Which is something that we can definitely find, right? Why?
Is it 1 to 1 check?
1 to 1 is correct, but why?
180 minus
Yeah.
22
Wait,
minus
okay,
6.
BFD, the next one is BFD, is this one over here. Yeah, can see? Can see this one over here?
Yeah.
So you can find this one, right? Fair enough. Can find this part over here, right?
Mhm.
True. So angle BFD, actually you can just use exterior angle of a triangle.
Yeah.
Okay, you can just use exterior angle of a triangle. Why do I say exterior angle of a triangle?
Because
You want to
it's
find this one over here, right? You want to see this one, find this one over here, right?
Yeah.
So you just have to do 68 degrees plus 53 degrees. We get to an answer of 121 degrees. We call this exterior angle of a triangle.
Oh, I got it.
Can you understand or don't understand? Understand or don't understand? Okay, so this is 1, 2, 1. Make sense or don't make sense? Okay, all right. So,
That's got it.
okay, so then next one I want to find is BDC. Where's BDC? BDC is this part over here. Can you see that?
yeah,
Okay, find whatever you can find first.
22 check.
22 is not correct. 37 is not correct. Let's, okay, one by one first. How about let's find this one first? Do you all know this? Do you all know this? AEB. I'm doing C already. I'm doing, yeah. I'm doing E already.
46.
46 is correct. Very good. Okay, angle AEB is basically what? 90 degrees minus away 68 degrees. Do you agree or disagree? All right, this is 22 degrees. Make sense or don't make sense? Make sense or don't make sense? This is 22. All right, let me just say this again. This is how much? 22. Do you understand or don't understand? Okay. Yeah. What else? Can you all try? Can you all try? Try it yourself. I am going to use a yellow color marker now, a highlighter, sorry, to show you another thing, okay? All right, and that is this angle over here. Can you see a butterfly? Can you see a butterfly? So that means this part is also how much? 22. True? Can you see a butterfly? Can you see this butterfly? Are you able to see the butterfly? See how I remove? Can you see? Can see a butterfly? Can see a butterfly? All right, so this is how much? 22. Am I making sense or not making sense?
Oh,
Okay. All right. So what you want to do here, of course, you want to write down first. What is that called? That is called angle what? Yeah, ADB first, right?
Oh,
Yeah, yeah, correct. Angle ADB is actually equals to also 22 degrees, right? Agree or disagree? This is called angles in same segment. Do you agree or disagree?
agree.
Sure? Understand or don't understand?
Yeah.
All right, then we are trying to find out what is this angle over here. Correct now? And this is parallel, ma. So that means this is also 22. True?
Yeah.
Make sense? Isn't this also 22? This angle over here. Can you all see my cursor? Can you see my cursor? Right? That is called CBD, right? Angle CBD. So angle CBD is also equals to 22 degrees. Why is that so? Because we call this an alternate angle. Do you agree or disagree? Do you agree or disagree? Okay, I'm going to erase the rest.
then
Okay.
BDC.
Then you can find angle BDC. All right.
180
BDC
minus or
equals to
minus
180 minus 112 degrees minus 22 degrees. That gives me how much? That gives me how much? 46 degrees. Okay. All right, so this is over here. This is 46 degrees. Okay, so that's how you do a question like this. Last one. Okay, so very importantly, SCT. Can you see SCT? SCT is what? Tangent to the circle. If SCT is tangent to the circle, what happens? Tell me, what is it? Yeah, which is 90 degree? 90 degree is this one over here. Can you see that? Do you agree or disagree? All right, so I guess that's the first thing that I can find, which is this one over here. Agree so far?
90 minus 30.
Okay, I go in this. Okay, they want us to find PBC, which is this one. All right, so okay, angle PCS. So angle PCS, again, I say the angle PCS is how much? 90 degrees, right? Right now.
Yeah.
So angle PCB is how much? 90 degrees minus away 38 degrees. That gives me how much? 52 degrees. Can you see this 52 degrees? Do you understand? BE intersects AC. BE intersects AC. Oh, very important. You can say vertically opposite. All right. So this is definitely vertically opposite because you can all see how important this sentence is. Just a simple sentence, correct or not?
Yeah.
All right. So that is angle
intersects AC.
BPC. That is how much? 61 degree. We call this vertically opposite angle. Am I making sense?
Yeah.
Okay. All right. This one is called rad. What is this called? This is called tangent. Tangent is perpendicular to the radius. Am I making sense?
Yeah.
Okay. Tangent is perpendicular to the radius. Am I making sense? All right. Do you agree or disagree? Okay. The 52 degrees is basically just 90 degrees minus 38. Can? Okay, so we know this is 61 degree, right? So can we find this part over here? Angle PBC. What is angle PBC? 180 degrees minus away 61 degrees minus away 52 degrees. Do you all understand or don't understand?
Wait, what's the reasoning for this?
What is the reasoning for 180 minus 61 minus 62?
Yeah.
52. That is angle sum of
Oh,
triangle. Sum of triangle. Sum of angle in triangle. Can? Okay, or angle sum of triangle. So then this becomes 67 degrees. You all agree or disagree?
Oh.
Okay, so I will just go one by one. Okay, I will just stop here for a bit for y'all to make sure y'all are done. Once everyone is done, then I'll move on to B. Now we start afresh. Okay, we see CDE. CDE is this one over here, right? Agree or disagree? Can y'all see it? Can y'all see this or cannot see? All right, so y'all drop really. Okay, for CDE, all you want to do is angles in opposite segment, correct? Can you see opposite segment? Can see? Right, why is this? Because can see this quadrilateral? Can see a quadrilateral or not? Can see?
Yeah.
Right, okay, so we find angle CDE. To find angle CDE, we just have to do 180 degrees minus away 67 degrees. Do you agree or disagree?
Yeah.
That is 113 degrees. Am I making sense or not making sense? All right, angles in opposite segment. Angles in opposite segment. Make sense or don't make sense? All right, yeah. So then we have this part. Okay, we already know this part. All right, so this part is 113 degrees. ABP, where's ABP? ABP is this part over here. Okay, I'm just gonna. Can see? All right. How many of you can see a semicircle? How many of you can see a semicircle?
Oh, it's just 90 minus 67.
Correct. Why? Angles, right angle in
Right
a
angle in a
semicircle.
semicircle.
Very good. Okay, so C is actually equals to, let's find ABP. So angle ABP. All right, where's the right angle? The right angle is over here. This is the right angle in a semicircle. Can you all see it? Or can you all see? All right, so let's basically just have to do 90 degrees minus away 60. Sorry, what 90? Yeah, 90 minus away 67. Do you understand or don't understand?
Yeah.
All right, we get to 23 degrees. Where's 23 degrees? 23 degrees is over here. Do you understand or don't understand? All right, so yeah, that's how you do a question like this. Okay, we just have to do it this way. You see for yourself, see for yourself, Can you all see? Can you all see this part? Can see? Can see?
Yeah.
Can see that this is a butterfly, right? Can you all see that this is a butterfly? Yeah, so this part is also how much? 23 degrees. Do you understand or don't understand?
Yeah.
Okay, this part is also how much? 23 degrees. Am I making sense or not making sense?
Angle
All right,
is
angle
also-
ACE is also equals to how much? 23 degrees. Okay? This is called angles in same segment. Do you agree so far?
Yeah.
All right, so yeah, that's how you would do a question like this. Hi everyone, if you like this video, you can click right here for a similar video or you can view our playlist here.